today's lecture, I'm going to be going through the residential footings. I'm going to give a good overview of how the footings work. We're going to go through and design some foundations, but you're going to learn the technical aspects of it in more detail in your geotechnical engineering subject coming up next semester. So first thing, what is a footing? A footing is a structural element which connects the house to the ground. Okay, what it does is it transfers all the loads that act on the house, the weight of the building or any wind, brings all of that down to the ground. It prevents settlement of the earth underneath it, and it supports the foundations. We've got different types of footings. We've got pad footings, which are over here, which are used to locate columns. So we have a column here, and what the pad footing does is just spreads out the weight or the load over a greater area. If you think about a pen and you try to put a pen through a bit of paper, it's a lot easier than if you try to do it with a texter. Same thing as if you're on the beach and if you're walking on the sand, as you walk across it, your foot will go through the sand. If you had some big platform underneath you, it wouldn't. Okay, the sand wouldn't settle. Okay, everything we do is by force by area. Our strip footings. So the strip footings are these ones here. They're starting not to be used as much anymore in Australia. What these are is these would be located under the walls of the house, and then your floor would just span between them. Waffle rafts are becoming more and more popular. That's these ones here. So what it is they put a polystyrene box on the ground, they put steel in between it, and then pour concrete all over it. Okay. The most common thing is the raft foundation, and that's what we're going to be designing. Pile foundations are usually used for bigger buildings or when the soil is unstable. So what's the process of how we do the footings? So what happens is a client will usually acquire a block, and they come to us and go, okay, we need to start designing a house. What do we do first? Well, we have to go through and build the footings. So a client gets the block, a vacant block of land. We then come through and we take some soil samples. So we drill through the earth, we drill a stable core, we pull it out. And then what happens is we put the sample in a box and we go test it. Now we test it by the visual tactile method, which sounds pretty fancy, but all it is visual. So we look at it, tactile, we touch it, and that's how we get our values. We have to go through and do some calculations about the movement, so how much the ground's going to move, and then we design our foundations around it. After we've done the design, our trades will go out and excavate the ground. They'll then after they've excavated the ground up, they'll lay a couple of tarp things on there, which we'll go through shortly. They put a bit of steel in the ground, and then they pour the concrete over it. Alright, so it's not a very big strenuous activity that they go through. It's pretty systematic. So here's some examples, or here's like the actual process. So we get a vacant block of land like this. This here is the drill rig on the back of a ute. They come up and they just start drilling straight through the ground. So they hammer it in, and then they pull the core sample out. So a big burly bloke will come in, pull this rod back out of the ground, and he puts it into a tray like this. Now each one of these is 750 millimeters. Alright, so this here is 3 meters, this here is another 3 meters. So we dig down to 3 meters per sample. Usually we take 3 per block. So usually what happens is we're looking for here, this is obviously the top of the earth, this here is the end of it. So we're looking through, this here is usually backfill, and this is really what we're interested in. This here, this red brown earth is a clay, and what happens with clays is when water or moisture comes to it, it starts to move a lot more. This here is a bit of a sandy gravel, so it's not too bad, it's not very reactive. But you will learn more of that in your geotechnical class. Once we've done our design, our trades will come in like this, and they start excavating through. So what they're doing here is just making a structural grid, basically ripping the ground into different segments. Alright, what we can see here is we can see the pipes are coming through. Usually we have to, if we can get away with it, we try not to. Here's a cross section of it. What happens is if we have to put a pipe through the ground like this here is a tape. It's a 40 millimeter like a foam tape that comes around it, and what that does is if there's any movement in the ground, it stops it from cracking our pipes, or it tries to. It doesn't always work. After that, they put on this Forticon. So this orange stuff here, which is also this blue stuff here, is called Forticon. That's the brand. It's a damp-proof membrane. So what it does is it stops any moisture from either coming up through the ground or coming down into the ground. Okay, this protects our steel and stops our building moving. So what they'll do is they'll come in, our steel fixers will come in, tie all the steel together, and then we pour our concrete on top of it. So this is the finished slab. They've come in, they've poured the concrete over the top of all of this steel here, and this is how it looks. So we have our pipework sitting up through. We have these things here, which is a set down. So usually what happens is we set down our garage, our wet areas, and our alfrescos in the porch by 50 millimeters. Okay, this is to stop any water from pooling or running into the house. Okay, obviously our wet areas are more prone to have water in them. So we set them down so if it fills up with water, it's not going to spread to the rest of the house. We will cover this more when we look at our site drainage and our site plans when we design our levels. This line here around the building, you need to pay close attention to it. This is our set down or our edge rebate for the outside of our slab. So what this is our brick course will sit in here. So this recess here is usually 25 to 30 millimeters, which we'll go through a bit later on. So how do we design footings? So there's three methods that we use. We've got deemed to comply, we've got probabilistic methods, and we've got SLOG or PodLock. We've got software that we can use. So SLOG stands for slab on ground. All right, so this here is our engineering principles basically. Probabilistic is based on historical data. It's pretty straightforward how to use it. What happens is they'll go through and register thousands of houses that have all cracked. We go, okay, what acceptable level of cracking can we have, or how wide can the crack go? How often was our probability of exceedance that will allow for this crack to happen? Come across, come straight down, and then we get our depth of our footing. So you will learn more about these in geotechnical engineering. For us, we're going to be doing the deemed to comply method. Okay, we're going to design by standards. So our standards are a more conservative approach. Being more conservative, they are a bit more costly for the client to do. So usually it is preferred to use SLOG, but deemed to comply is still used quite often. So what is deemed to comply? It is just our standards. It's the AS2870. It's the residential footings and slabs. Residential slabs and footings. This is a cross section of a raft foundation. This is what the concrete looks like, taking a cross section through the earth. So what happens here is obviously the trenches that they've dug in. All right. Here is the earth in between, and then we've poured the concrete on top of the steel. So we'll be looking at this over and over and over again. So just take a couple of notes as to what's here. I'm not going to be going through the entire standards with you. I will show you elements of it, and I will explain more of it, but we're not going to be going in detail. So our footings are 300 millimeters wide, given here. The reason for that is if we go every 100 millimeters, we go bigger than this, we have to put extra steel top and bottom. So there is lots of little things that I will just mention to you, but we're not going to go through in detail. Please also note, a key thing is your depth is from the top of the slab to the bottom of the footing. It's not from the edge of the rebate. So this here is just taken straight out of the standard. This is about our continuity. So all of our beams have to run in a structural grid, so they come straight through. So none of them will just come and stop, they all run the whole way through. This will make sense when we start actually drawing some footings coming up. So please just take a mental screenshot of this, and it will make sense as I go through it. We have center to center spacing here, which is a key. Our first footing cannot be any more than 4 meters from an edge in either direction. So please also take note of that. So this is how we design our footings. This is a key table to design a stiffened raft foundation. So what happens is they come through, once they've done the calculations on the soil, they can classify the site. Alright, so I will always give this to you. You will learn how to classify in geotechnical engineering, but we have to learn how to do the cross sections and footing layouts now. So say I've given a H2D site. This is the type of construction, what the wall is made out of. So usually we're going to go with an articulated masonry veneer. It's usually what we're going to use. Clad frame is like the Hebel panels. It's starting to become more and more common. It's a lightweight construction. So what happens is we go site class. So we've got our site classification. We know our type of construction. So we just start moving across here. So articulated masonry veneer. The depth is the next one here. So depth, which is the top of the slab to the bottom of the footing, is 700 millimeters. We then look at this table here and we go, this has got some funny words to it, or some funny lettering, so we ignore it. Okay. This here, this L11TM, is trench mesh. It's not used here in South Australia. It's used interstate, but not here. So we just ignore this column. We move straight across to the next one. This is our bottom reinforcement. What we're using is 3 N16s in the bottom. Our top reinforcement is 2 N16s up top, and we've got 4 meters spacing, center to center of our footings. So it's pretty straightforward how to use this. We're going to be going through it numerous times, so it's going to be quite repetitive. So you're going to become very good at this. The other thing you need to note is the slab mesh. It's all dependent on the length of our building. Okay, so when you get a floor plan, when we're designing foundations, measure the overall length, and that's what's going to happen, or the size of the mesh can be determined from there. This is a typical cross section. Okay, so remember our H2D, articulated masonry veneer, 700 millimeters deep, 3 N16s in the bottom, 2 N16s top. So what have we got here? We've got 2 N16s top. We've got 3 N24s in the bottom. Alright, so this here is a lot thicker or bigger steel in the bottom. The reason for that is this soil could be a lot more reactive. So this is probably done by the slog method, not by deemed to comply, but it's the same principle. 700 is measured from the top to the bottom. We know this is 300 millimeters wide. Everything else we will go through. So the mesh is determined from the length of the building. This here shows that it is a brick veneer. This here is the brick. This here is our timber stud. This here is our thermal gap. So it's a brick veneer house. We've got our Forticon, or our damp proof membrane, DPM, that runs around the inside here for our water protection. This here is the ligatures, which will always be given to you. I will always give you this value. You've got 100 millimeters of blinding sand. This here is just to allow a stable level to come through. Alright, so you will need to just remember that usually we have 100 millimeters of blinding sand and 100 millimeter slab. You'll need to know this when we look at our site levels. 100 millimeter slab can change depending on our soil. If we have over 200 millimeters of backfill on our site, we increase this by 25 millimeters and we put 2 layers of mesh. But you will learn that further down the track. So footing layouts is like this. Everything is continuous. When we come to it, in my next video, I will show you how to do a footing layout and the best way to start it. But what we can see here is our garage is set down. Our wet area is set down. Another wet area is set down. This here is our porch, which will be on another level. And obviously all these dashed lines here are our footings running inside of our building. These 3N12 bars are 2 meters long. These are for our re-entrant corners. So when a corner comes in and then comes back out, it's a re-entrant corner, and we just put these here for our crack control. So that is in the standard. Again, you will learn that down the track. Usually we do not put in measurements for our footing layouts. We check them, so we make sure that our centers are less than 4 meters, but we do not put measurements on here. They get them from the floor plan. So here's what a detailed footing layout looks like. These here are for the control joints, which we're going to ignore in our course. You will learn that down in geotechnical engineering. but this is the kind of level that you will need to get to. Okay. So what you can expect. So what's going to get given to you is you're going to get the wall type, the site classification, the construction type, or the wall type. Sorry, I've written that twice. You're going to get the slab cover, the slab length, which will be given to you by either in a drawing or it will just be written to you. You'll get the footing cover. So the cover is a distance from the concrete to the steel. So from the concrete to the mesh and from the concrete to the ligature. You'll get given the slab thickness and you're going to get given the ligature size and the spacings. So what are you going to have to do with that information? So you're going to have to determine the slab mesh, you have to determine the footing reinforcement, the footing depths, and you have to draw a cross section. So next I will draw a cross section and I will draw a footing layout, which you'll have to follow. So this is a typical footing cross section that I showed before. All of this can be determined from page 30 of the standards, which was that table that I showed you before. So that's our footing overview finished. So thank you. I will see you in the next video.